In this section of the course, we'll be looking at how to use sigma notation accurately. Right, what is sigma notation? Sigma notation is a capital Greek letter sigma. This means sum of. Sum of the terms, sum of the first 5 terms of this series indicated by this arithmetic sequence. So, first of all, let's see what are those numbers. How do we start? This lower value, r equal to 1, means that use value of r, substitute 1 into the equation, and that would give us the first term. What does that 5 mean? That 5 means that this sequence has only 5, so you need to go from the first to the fifth term. And if we actually calculated one term at a time, we will see that what happens. So we said the sigma is the Greek letter which indicates to add up. The, the nth term is written in front of the sigma, and in this, don't confuse this r with the common ratio. This r indicates the index. Different questions have different letters. Sometimes it's letter I, sometimes it's R, sometimes it's J, sometimes it's K, and sometimes it's a different letter. It doesn't matter what it is, it's just an index. Alright, we said that 5 indicates the last term of the sequence, or the position for the last term of the sequence. If we actually substitute the value of 1 into this formula, we get -1. And then the next number would be 2. If we substitute 2 there, 2 minus 3 is a 1. And so on. 3 would give us 3, and 4 will give us 5. And substituting 5 would give us 7. Of course, we're not going to do this manually. We have a quicker way to calculate this sum. But I'm just showing you as an example. The correct way to tackle this problem quickly is to figure out what's the first term, what's a, first, and then we look at the formula. This is clearly an arithmetic formula, arithmetic series. What's the common difference? Just looking at this term here, the multiplicative factor is the 2. So that's the number that each of this that will tell us what's the common difference. The common difference is a 2 because of the fact that we are multiplying by the index by 2. So you collect a, the common difference, and n. You read n from the top here, and then you would substitute into this equation, and this is the quickest way to find the answer. It's 15. Of course, this one and this one cancel each other out, and these 3 add up to 15. Now let's look at more complicated example of sigma notation. In this case, we don't start with a 1. We are supposed to start our sum with the third term, going from the third term to the seventh term. And looking at the formula, it's not an arithmetic sequence. What kind of sequence is it? It's a geometric sequence. Just once again, this means the sum of. You're going to use the first index to be 3. Okay, the way I would tackle this problem is figure out what's the value of a, which in our case is going to be 3 substituted into this formula. 5 times 2 to the power of 3 is 40. 5 times 8 is 40. I would take a to be 40. The common ratio is obviously 2. If you don't know why, you can figure out 2 terms of the sequence and divide them by each other. The fact that 2 is raised to a power means that 2 is the common ratio. So r is 2. How do we know how many terms are there in the sequence? Most students make the mistake of thinking it's 7 minus 3. but actually because the third term is included in the sequence, is 7 minus 3 plus 1. So if you don't believe me, just write the numbers out for yourself. Third, fourth, fifth, sixth, and seventh. How many numbers are there? It's not 7 minus 3. It's actually 7 minus 3 plus 1, or 7 minus 2, which is 5 numbers. Okay, so we know how to find sum of a geometric series. We can simply either use this formula or this formula over here. Okay, so we're going to grab that and just put the numbers into the equation. A, R, and N. So substituting them into the equation will give us this answer here, 1240. Now let me clear my writing here. So, and if you actually had to figure out the actual numbers, it would be these values. Okay, I've just factorized the 5 out of each, so it will be easier to note them down. All right, so let's look at a few more examples. In this example, I'll show you a long-winded method as well. Okay, so it's an arithmetic sequence. It's not an arithmetic sequence. It's a geometric sequence. What's the first term? Okay, the long way of doing it is to calculate the sequence from 1 to 15 and calculate another sum of the sequence from 1 to 5th, because the fifth number is not included in the sum. 1 to 5th is not included. So we're going to do it the long way this time. It's like calculating and using this formula given to us in the book. It's just saying that 1 to n is going from 1 to k minus 1, where k is this number where we would start with. But I think my method is quicker. But let's quickly have a look at this as well. So you would go from 1 to 15 using this formula. You would say, what's the first term? It would be substituting 1 here. 1 minus 1 would be 3 to the power 0. So the first term would be 5. And the common ratio is 3. So you would use this formula from 1 to 15. You would get this sum. Alright, this is a huge number, 3,587,000. Now then, you would find the sum of the first 5 terms, because we're supposed to start from counting from the 6th. So sum of the first 5 terms is used again, using the same formula, only using a power of 5 here. Right, when you subtract the sum of 15 minus the sum of the first 5, you would get this number, 3,587,000. Actually is 35,871,660. Now, the quick way of calculating this would have been to actually count A to be the 6th term. So I'm going to write it with a different color here, purple. Alright, A is when you substitute 6 for the index into the equation, and then you say our numbers are 15 minus 6 plus 1, or rather 15 minus 5. There would be 10 terms in our sequence. Then I would substitute n to be 10, and I would use the value of a to be just 5 times 3 to the power of 5. This would be the 6th term actually. Okay, so put that in your calculator and you'll see you get the same answer that we did with the long method. I think this shorter method is much handier. This can be applied to arithmetic sequences as well. You just find the first term with the arithmetic formula rather than the geometric formula. Alright, so if you had to calculate an arithmetic sequence like so, what would you do? I wouldn't use this method. I would prefer to say my first term is when I substitute 100 into the equation, so it would be 300 plus 4, which is 304, and I know my common difference would be a 3, and the number of terms would be 200 minus 100 plus 1. So that would be 101 terms. Then I would use this formula here. Because this is an arithmetic sequence, its sum needs to be an arithmetic sequence formula. So I would use sum of 101 be 101 over 2 times 304 plus n minus 1, which is 101 minus 1 times the common difference. Alright, so good luck practicing. I'll see you in the next video.